Hi everyone, today I will teach you about diazotization reaction. In order to have diazotization reaction, we are going to need a phenyl benzene, and this phenyl benzene we need to react with nitrous acid, and we produce nitrous acid using this reaction over here. So we have NaNO2 with concentrated HCl. They are going to give you HNO2, which is the nitrous acid, and NaCl. So we will require the HNO2 over here. I'll put it over here. And we still require the concentrated HCl. Okay, I'll just put it here. This is concentrated HCl. And they are going to give you a salt, okay, which is going to be named as benzene diazonium salt. So they will look like this, N double bond N, so plus Cl minus, okay, and then plus water, and they are going to be 2 moles of water. If you are wondering what happens, okay, so you can see the nitrogen and nitrogen, okay, they will come over here, and then the Cl will come over here, and you are going to have, okay, you are going to have this particular product, and we are going to have 2 hydrogen atoms, 1 hydrogen atoms here, 2 oxygen atoms here, and another 1 hydrogen atom here. So what is going to happen? You are going to get 1 mole of water here and another 1 mole of water here. So you are going to get 2 moles of water. Now, once we have this, this is going to be, again, I write it again, it's benzene diazonium salt. And this benzene diazonium salt, we do not need the entire salt. Okay, we just need the ion. Okay, so I will just take the ion over here. So I will put it N2 plus, still the same, N double bond N. We remove the Cl, okay, the chloride ions. And you are going to go through a reaction, what we call as coupling reaction. Now, the coupling reaction will produce the dye, and we are going to use phenol in this case. Different coupling reaction produces different dye. Okay, but before I forget, this reaction earlier, okay, must be kept with the temperature that is lower than 10 degrees Celsius, because we want to prevent the benzene diazonium salt to decompose to give you nitrogen gas. So it must be done below 10 degrees Celsius. Now, so in coupling reaction, what is going to happen? Basically, we are going to have this as our electrophile. So electrophilic substitution is going to happen, and take note that OH is going to be 2,4,6 directing group. Okay, they are electron donating group. So they are going to activate certain position, but in this case, the position number 4 is going to be activated because of the size. Okay, so it is better to attach them in position number 4. You are going to get this structure. Let me draw. N double bond N join with this position number 6, and you are going to have the phenol over there. Okay, and do remember, because it's a substitution reaction, there is one H over there, so this H will come out. Okay, so plus H plus. Now this is what we call as Azo Dye, and this molecule, this particular molecule over here is going to be orange in color. Okay, but okay, if you have different molecules, for example, if let's say we are not using the phenol and we want to use some other thing, okay, we can have different dye. For example, okay, the same process, okay, the same reaction, okay, but the coupling, if we actually change the molecules to be coupled, okay, we are going to get different colored dyes. Okay, for example, if we are reacting with this compound CH3, CH3, we are going to get, Okay, almost similar. N double bond N. Okay, join directly to this benzene, and then you have NCH3 CH3, and then again plus H plus. Now this is also known as Azo Dye. Okay, but now because it's different structure than what we had earlier, so this is going to be yellow in color. So different formation of dye. Now please take note, azo dyes, okay, they are very stable, okay, because the pi system, okay, will become delocalized between the nitrogen and nitrogen bridge. So this is going to make the azo dye to become more stable, okay, and it will not be broken with heat easily. So please take note about as diazotization. So this is going to be the explanation about diazotization reaction. Thank you guys. See you. Bye.